your MapReduce. Okay, job scheduling, the execution system. You have a HBase here, that which we will be talking later. It's just a database which does not use MapReduce. Okay, all other components basically live on MapReduce literally. Pig is one particular component or one utility which we will be studying today. Other than Pig, we have Hive, we have Scoop and other stuff. Zookeeper is a coordination service which runs in parallel, and Avro is a serialization service, which are all optional. See, you have hell a lot of tools, so many tools. Now I can keep naming them one by one. Now learning each and every tool does not solve two purposes. One, you really don't require each and every tool to be learned. Point number two, okay, message from Anil. Okay, so where was I? Yes, so it really does not solve two purposes. First one, you don't need each and every server, each and every component. Second point, as I speak, there would have been another 5 or 6 components that would have popped up, and it is impossible to learn each and every component. Okay. However, we have been speaking about components that are real essential. Okay. Now we'll be speaking about Pig. Now Pig stands here, which sits on top of MapReduce and HDFS. What is Pig? Now Pig is an open source high-level data flow system. Okay. Pig provides a simple language for queries and data manipulation. Pig Latin is basically the language. Okay. Pig Latin that is compiled into MapReduce jobs that are run on Hadoop. Pig is a tool, and Pig Latin is the shell where you kind of script. Okay. Or rather, Pig Latin is not the shell. Pig Latin is, how do I put it, is a language. Okay. Pig is the name of the tool. Grunt is the name of the shell. This might be funny because grunt is the sound made by pig. Pig is your name of the utility. Okay. You have a grunt. Grunt is the shell. In your Unix box, when you type pig, it takes you to a grunt shell. And Pig Latin is whatever you type inside your shell, the language which you use is called Pig Latin, which is similar to that of kind of Python and SQL. Okay, so 3 things. So Pig Latin that is compiled into MapReduce jobs that are run on Hadoop. So Pig Latin is a language which is basically compiled, and it basically triggers a MapReduce job internally, which are run on top of HDFS. Okay, Pig Latin combines the high-level data manipulation constructs of SQL with the procedural programming of MapReduce. Why is Pig important? Companies and organizations like Yahoo, Google and Microsoft are collecting enormous data sets in the form of click streams, search logs and web crawls. Some form of ad hoc processing and analysis of all this information is completely required for them to survive, either to sell ads or to do the reporting or whatever purpose they want the data. The data is available, but you need a tool to process it. We have MapReduce, yes, but it has its own share of negativities, like the code maintainability is a real tough ask. Point number 2, it is really difficult to code. The level of complexity is high. Point number 3, to even write a simple query, you need to write so many lines of code. So you have certain negativities which creep in. So basically you can go for high-level languages like Pig and Hive, which do the work for you. So let's see what the existing solutions are. We have parallel database products like Teradata. Okay, Teradata. It is expensive at web scale. Okay, Teradata is a solution which is highly costly. You can see the slide number 1 where you can see this RDBMS there, right? See here you can see, where's my mouse? Yes. So you can see RDBMS here. So basically how the flow happens is that we have this big data concept which is done here, and then we kind of cleanse it, we transform it, and however we want to do it, we do it with either the help of MapReduce directly, that is raw MapReduce, or we take the help of Pig and Hive. Okay. On top of this, we use RDBMS. I mean, we dump the filtered data to RDBMS, and we use that data in RDBMS for reporting, for getting point updates, point queries, and all those things. Okay. So basically, this is how ideally stuff works in a huge organization in a well-planned manner. Okay. Teradata's UI, not the UI, the language that we use is absolutely the same as SQL. You don't need to learn any new stuff when it comes to Teradata. Okay, probably it might be on the minutest of scales, but yes, for starters, first one, it has the hardware cost is really high. Point number two, if I have to draw a diagram to describe how stuff is in the current world, if this is Oracle and RDBMS for you, here is your Teradata, which has higher storage capacity and faster processing or parallel processing, and here is your Hadoop, comprehensively higher, comprehensively ahead, okay, in terms of handling huge data and processing huge data. Okay, so this is the scale. Okay, but one thing if you can observe from here is that no technology is here to replace the other technology. Okay, we are not talking about Hadoop as a replacement to either Teradata or to RDBMS. Okay, so these three technologies will remain the kingpins in its own domain. RDBMS cannot enter into, they have predefined boundaries. Okay, they cannot step into each other's boundaries. Yes. So this is RDBMS. I'm just trying to jot down a visualization, jot down a chart where it will be easy for you to visualize. RDBMS. This is RDBMS. This is your Oracle system and stuff. Okay. This would handle a limited amount of data. It cannot handle a data beyond a certain capacity, and it does your normal processing. This is Teradata for you, where it will handle more data compared to that of RDBMS. It is higher in terms of storage when compared to RDBMS, and this is Hadoop, which is really above the scale in terms of the amount of data it can store and the amount of data rate at which it can process the data. So what I am trying to ask you is that do you agree where Teradata is placed? And I was also telling you the fact that no technology is here to replace another technology. It's just that we are filling the gap. Okay, you have in small organizations, you have to have this particular concept. Yes, in small and medium-sized organizations, you have to have this concept, and in huge organizations, you have to have this concept as well as, if necessary, this concept as well. It's up to you, or this concept, either ways. Coming back to the topic, now, one thing which I want to tell you was that in Teradata, it's basically SQL queries that you write. Okay, so yes, existing solutions we have done with Teradata. Next, raw MapReduce. Now, why don't we go for raw MapReduce? Why do we go for PIC? Complex n number of stages data flows are not supported. Joins and related tasks require workaround or custom implementations in raw MapReduce. This results to a code which is difficult to reuse and maintain. Hence, we go for PIC, which is a high-level language. Language features. First one, several options for user interaction. You have three ways to interact with PIC. One is through the shell mode, interactive mode, that is through the backend, through PuTTY, through your grunt mode. I did tell you that if you open your PuTTY and type PIC, it will take you to a mode called grunt mode. Grunt is its shell. It is the console mode. Okay, through this you can interact. You can write queries there and you can run PIC. Second way is to write a file, like a script file, .sh file. In scripts we have .sh file, right, or .ksh, however you call it. In PIC you have .pig files, okay, .pig. They basically contain your PIC code. If you can trigger that particular file and to indirectly trigger the code which is inside the file. Okay, this is called the batch mode. Prepared script files containing PIC Latin commands. The third way to interact with PIC is that you can embed your code, PIC code, inside your predefined language. If your language you are using is Java, then you can embed your PIC code in Java language itself. Okay, so you can embed it also and then you can run the code. As in when you run the Java program, it will automatically trigger your PIC script as well. Okay, so you have three options. Now, PIC is basically primarily built for scan-centric workloads and read-only data analysis. Next, third one is it is flexible, fully nested data model. Fourth point is that it has extensive UDF support. UDF is basically user-defined functions. Now assume, that I told you that PIC internally creates a MapReduce program for you. You don't need to sit and write a MapReduce program. Now assume that if you were a MapReduce programmer, you would have coded your map class and your reduce class in a specific way, which is different from how Pig creates it for you. Okay, somehow you are not happy with the way with the map and the reduce classes which Pig creates by itself. You are not happy with the way. Probably optimization issues or any such issues. You are not happy. Okay. Now in such cases, what you can do is you can define your UDFs, user defined functions. You can create your own function and you can guide Pig. Nobody, this is not the way you do it, but rather this way. Okay. You can trigger that function which you have made and you can make that function run. Okay. So not just this, you have hell lot of features when you come to UDF. Okay, but as of now, UDFs are supported only in Java. Okay, it does not support any other language for now. UDFs can be written for filtering, grouping, or tuple processing. Tuple is like a bag of data. Okay, so bag processing, loading and storing. UDFs can be used for anything and everything. So Pig accepts UDF as well, user-defined functions. Now, Pig Latin editors. How do you do it? PigPen is an Eclipse plugin that provides an environment for developing Pig programs. For starters who are not used to Java, Eclipse is an IDE, okay, which we basically use to build Java. Okay, it includes a Pig script text editor, an example generator, and a button for running the script on a Hadoop cluster. So you can basically execute that Pig script straight from Eclipse, provided you have a proper connection to your Hadoop cluster. That's all. Okay. Now there is also an operator graph window which shows a script in a graph form for visualizing the data flow.